All right, and we are live. For the first time in a while. Like, when was the last time I streamed? Because it has been a hot minute, hasn't it? Let's see this. YouTube Studio, when's the last time I streamed? Because last time I streamed on Twitch, it was, I was like working on my car. And that was the time before last that I dropped the transmission out of my car. This was probably like a month ago. Let's see. The last one I did was January, February, March. Okay, so like 2 months ago. So it has been a hot minute. Okay. So, what are we doing today? And what is with the cryptic name? And aren't I done streaming and all of that? Well, I'm not done streaming. I've decided that I like streaming. I like streaming a lot. Streaming is refreshing, it helps me focus. I'm not sure if I like making YouTube videos though. We'll see if I do actually make any YouTube videos in the future, but I'm definitely going to keep streaming because I do enjoy that. I'm also like not completely done making game engines for the moment, though I do have Brain Engine on hold until it actually becomes like financially viable project to finish. So in the meantime, I am just experimenting and having fun, and also I want to learn how to ship things. How do you actually publish something? Because I spent 5 years on a project and like nothing's released. I have stuff to show for it, but I don't have stuff to show for it. I can't, like, the flashiest demo I can do was from 2 years into that 5-year project, which is like the whole like upload a thing to a server, download it from it, and like the triangles go in one by one. But like that's the flashiest demo I can do, is just that. And 3 years after that, it's like, okay, you can kind of use BrainScript from a command prompt, but other than that, not really. Anyways, so right now I'm working on I have a couple of projects I'm working on in my spare time, but one of them is just a small engine that I want to try to use to make like just small games to play with friends, basically. Like it doesn't have to be perfect. Anything in this engine can go. I build it, I use it to experiment around with ideas that I have, and it's not too far along. Like I have Vulcan Triangle done. But the other thing gnawing at me is I really do like metaprogramming a lot. I want to be working in a language that has a lot of metaprogramming. I like Rust, but see, seen Resonite's Resonite link? Yes, I have. It looked very impressive. I haven't actually messed around with it. Dang, is there just a scratch on this drawing tablet right over where your words are? No, that looks like a piece of tape that didn't fully come off. Anyways, yeah, so I haven't fully decided. I thought I had decided what language I wanted to write that engine in. I started working with it in just Rust. I experimented with the idea of writing it fully in C, just for the fun of it. I have decided that for that just experimental engine, I did want to. So it's weird because I want to ship things, but I also want to I want to actually learn like the Windows windowing API, for instance, which turns out to not be that complicated. I don't know why I've been using GLFW3 all this time, when like it just took me like a couple hours to actually set up a windowing system, about as long as it took me to figure out how to link libraries the first time I set up GLFW. So maybe I'm just much more competent as a programmer than I was when I was using GLFW, but now it's like, yeah, basically I've decided anywhere that actually touches the hardware, I want to write that API. So Windows, there's a lot of stuff you can do with Windows to make the experience of your application better. Therefore, I want to be the one doing that. I don't really care about, like, I don't need to write a math library. I don't need to write that. I'm not going to write the best version of a math library. Artistic taste doesn't really matter there too much. A lot of objective, that is something where you can be like super objective about, like, you know, it just needs to be fast and work. For like a GLFW loading library, like I don't need to write that unless it's like super slow. But like anywhere where a player would actually interact with the thing, like I actually want to touch that. Anyways, I have all these different ideas of like things I want to do with the engine, and I also want to ship with it. But also, oh right, the reason I was going to say I was saying all of that was like a really good language for doing all of that really low level like API stuff is like C is very good at all of that. And the problem is like I did like a test project where I have this idea for a C toolchain I was thinking about making, where like I wanted to basically write a version of CMake where instead of it being like weird scripting language, instead it was literally like C files. They were compiled and then dynamically loaded, and then those were basically run as scripts to define CMake scripts. Which is a very over-the-top idea. But I tried writing this thing to compile C in C because I was going to be dynamically linking C to tell me how to compile C. And I learned stuff like, oh, to interact with the file system, I'll have to do like OS native stuff. And yeah, I ended up spending a lot more time on just like would have been a single iterator call if I wasn't using C. So I'm like, I don't know how viable this idea is. And then like, if I were to use Rust has a ton of packages, and those take care of a ton of things. But if I'm interfacing with all these low-level libraries, I don't really want to use Rust safe abstractions for things. I want to learn how the API itself works. I want to be able to follow the actually like commonly I want to use the commonly available tutorials for a ton of things, which they're all going to be in C and C++. So like I want to use C APIs. Rust is an absolute pain to work with C APIs, which I learned by implementing Vulkan Triangle using just C bind-gen binding. So I was essentially writing C in Rust. Now, Rust borrow checker stuff, and to be honest, I don't care about the borrow checker. I like everything about Rust, and I do like the memory safety guarantees that the borrow checker gives me, but for a lot of the type of coding I'm doing, it does slow me down when I know that I'm like doing things correctly. I'm not one of these like, oh, Rust isn't worth it because it makes me a slow programmer. No, I really like Rust. But for the type of development I'm doing, memory safety doesn't matter as much. Memory safety doesn't mean fast. Memory safety means unhackable, basically. It doesn't mean a perfect program. Literally the only thing memory safety means is a hacker can't RCE you with a pointer exploit. There's a bunch of other stuff from Rust that I do like errors through return types, the enums, I really like those. I really like the pattern matching. If I could have all of those features in C, that's the sort of language I would want to use at this point. But I'd also like, I'm not the biggest fan of the way Rust macros work, because I wish they had a little bit more access to type information instead of being purely syntactic. A more sane version of C++'s templating system is kind of, that's my ideal metaprogramming system. Anyways, so why the title of the stream? Well, I thought like, okay, I've had this idea for a while. What if, instead of writing a programming language, I wrote a system, maybe a language? It doesn't actually have to be a language, which was the realization I had earlier today, basically. Which is, what if I had an interpreted language, and I wrote a script in this interpreted language, and then running that script was a part of a compiler toolchain. So the reason I don't like dynamically typed languages is because they have errors that you don't find out until the code is running. And that goes for like all software, but dynamically typed languages, like the structure of your language can be wrong. And then it's something that could be statically checked in other languages, but it wasn't in the dynamically typed language. If you're only running the dynamically typed language at the compiler stage, and you essentially get full code coverage because you just run the entire script and then it's done, I'm fine with that. Suddenly, runtime errors of the script become compiler errors, which I'm fine with. That's exactly what I want. So, what if we had a compile time language that was dynamically typed in all of this, and then we use that to generate a program? So we could do a ton of metaprogramming using this language, so you have a single path compiler that's just running this language, and then that outputs C code. Now all of a sudden, like, I can write templates in my metaprogramming language, and then it just gets outputted into C, basically, which is how a lot of languages start out with a C backend. But this is more explicitly like, what if I could swap out that backend for like which language it was emitting to? What if I made a system that isn't a coding language, but instead a way for writing generic functions, and then those functions can be expressed in any output language, which technically I could have this thing emit directly to assembly, but for the time being we'll just do C because that's what's compatible with everything. I get all the metaprogramming I like. It's single pass, so it's like fairly fast, whatever form of dynamically typed language I choose. It's if I want any static validation, suddenly I write guards into the metaprogramming system, and if those throw errors, those then become LSP errors. So yeah, that's just what we can do. Is dynamically typed language generates a statically compiled language, and then we run that code. And that's the idea behind this. And it's not a new idea. In fact, there's something that is pretty much exactly what we're about to try to write, which is called Terra. It's not exactly what we're going to write, because I'm going to start out with raw Lua at first, with just adding types to it, and then output and maybe a runtime around it. Whereas they've gone and they've edited the runtime itself, they've edited the parser, which might be something I'm interested in doing eventually, especially for adding things like match statements, which Lua doesn't have. But like the core idea, and they make the exact same points that I do, which is the design of Terra comes from the realization that C and C++ is really composed of multiple languages as a core language of operators, control flow, and function calls, so that's your C++. But surrounding that language is a meta-language composed of a mix of features such as the preprocessor, templating system, and struct definitions. Which, like, yeah, the preprocessor is literally like, it's a completely different syntax. The C preprocessor, like, you know, the hash define, hash if define, all of that stuff, that's an entirely different language. You could use the C preprocessor on any document. It doesn't have to be C++. It's a completely disconnected thing. Then you have the templating system, which that's basically the type system of C++, but the syntax is different. You're using alligator braces everywhere, or I guess triangle braces, whatever you want to call them, everywhere. And you have to make giant, like, pure functional expressions out of types and whatnot, which I got fairly good at that. I really enjoyed that. This is what I want access to, but not the C templating system, because it is, I want to have the power of the C++ templating system without the syntax or environment or the C++ templating system. And then I don't know what they're going on about struct definitions. That's just like, here's how you structure data. Templates alone are Turing complete, yes. Have been used to produce optimized libraries such as Engine. And also, like, if you think about like Rust and their they have similar things where there's a parser library I've used called Chomsky, and basically all of the computation of that library exists in the templating system. It's crazy. And really hard to debug. That's the other thing behind this idea is like, if your metaprogramming system is just a script that runs instead of like this huge, like super deeply nested syntax, errors should be a lot easier to report and understand. But yeah, so Terra, amazing thing, go look at it, it's cool. We're not going to use any of it, we're going to make our own. Mostly because they're very JIT focused. They're like, this is similar to Lua where it's something you can embed and use, so they have like JIT comp. This is very much you embed it in a thing and then JIT compile. It's not sandboxed, so no, this is not like BrainScript. BrainScript is very much like sandboxing JIT compiled sandbox. Yeah. So I'm not going to use this because I don't think it has the same exact goals as I do, but the idea of the compiler toolchain is very similar and the same. And I think we're also going to use Lua, even though I could use any dynamically typed language. I could even use a statically typed language if I really wanted to, but like we want the toolchain to be fast, and a dynamic language actually in this case gets that for us. Yeah, so I called this pillar language because this has gone through a lot of revisions. This is like, what if I were to make my perfect language? And I don't think I need to actually make this a language at first. We're just gonna use Lua. So it's gonna be a compile time function generator and without a language that outputs other languages. Or I guess you could call it function definitions. And it is a JoJo reference because pillar, if you get it, you get it. And then I have a number of goals for this. Main one, fast compile times. I really want hot reloading. Well-defined interfaces for other languages. So, if the entire thing is scripts that run at compile time, hello Twitch. If the entire thing is scripts that run at compile time, let's just say we can't have a script that reads a C header file, and then generates our own bindings at compile time for that C library, which is something I intend to do. I want this initial version of the language to have full compatibility with C libraries, because if I'm going to use this, I want to be able to use libraries, because I want to be able to publish stuff with this. My entire thing right now is I want to ship code. I don't want to spend 5 years on anything I'm doing until I get back around to BrainScript. I want to actually be putting stuff out there. And that's also why I'm like, let's not actually make a language, because I looked at all of my ideas for this language and I'm like, the actual compiler time VM doesn't need to be something I write. It looks a lot like Lua or Python. I don't like Python syntax. Lua is tolerable, so we're going to use Lua. I do have LuaJIT installed. Nice. Yeah, actually. LuaJIT or Lua? Yeah. Do I have libraries for Lua? I have a DLL. I don't know if that's I don't know if I can link directly to that, but yeah, we can grab other binaries here and link to them. But yeah, so the idea. We write Lua, the Lua outputs C, we can run the C. Other ideas for it. Right, well, yeah. So I guess now, since I've decided I'm just going to use Lua instead of my own thing, we don't need to write an initial interpreter for this language. But we will have two emitters. No, I'm going to have one emitter for now. I'm not going to worry about a JavaScript emitter. I originally had this idea of like, what if I made the one language I use for everything, including the web, which means that I would have to have a JavaScript emitter. If I want this scripting language to be useful, JavaScript is pretty useful, so it could output that, even though I hate JavaScript. But yeah, C and JavaScript immediately accounts for every single major use case. And then standard library that's intended to function for the majority of emitters. So we need to find our virtual machine, basically, for lack of a better term. That's why LLVM is called low-level virtual machine, because it defines a virtual machine that can run on any hardware, and then its bytecode gets lowered into the native bytecode of, well, not bytecode, intermediate representation gets lowered into any of all those. People like the utility of JavaScript, what it can do, which is it can make them money because the web is JavaScript. That's the only thing to like about JavaScript. But yeah, and then this is the idea: is we make as small a subset of core functionality as possible. We implement that very small subset of functionality in our C and optionally JavaScript emitters, and then we write the rest of the framework around that, since we're not doing a language anymore, we're just doing a generator. And I have possible grammar examples I was working on, where I was doing this weird thing of like, I could basically do Rust, like borrow checking, but without a borrow checker, by just doing a dependently typed system. What was the term for it? A linear refinement type system. I could have done Rust borrow checking with a linear refinement type system, which we might still do some form of linear refinement, but don't necessarily need to do that right out of the gate, because I want this to be usable. It's a larger reason for this being a thing. So right now, it's a cool idea and I want to try it out. That's the main reason. And if I really like it, I might use it to make a small engine to play around with stuff and make small like games for friends. So mostly at this point, it's for fun. But basically, I really like metaprogramming, so it's an environment where I would basically be able to write C, but I would have a better macro system and be able to write my own form of templates and all of that stuff. Yeah. So I'd get like all the functionality of that and whatnot. So how do I want to start this out? Because now I've like explained my ideas for all of this, but what's it actually look like? So I have a fork of this repo, not a fork, a branch. It is now Lua, which is not pushed, so it's not showing up yet. And we need to decide. So we have these different things. Ignore all that. Which over here we have oh, it's just scaling, it's not zooming. There we go. Or not scaling. Blech. Anyways, so over here we have the idea of an different emitters, different backends. And these are going to be implemented in Lua. So we have C backend, which is the only one we need to worry about for now. So that's where I'm going to leave it. Oh yeah, no, the thing you're thinking of, or not thinking of, implying exists is Terra, where it's Lua, but they use it to generate just assembly. But I want to make my own thing with slightly different goals. Because this is for optimized, like, actually build a thing with it, where that's like embed it in a thing and have like JIT compilation and stuff, which is not what I'm focusing on here. So we have our backends, and then the backends are... Here we have our actual source files. These use a generic emitter interface, which I don't think actually exists in Lua. So essentially just uses the backend, and hopefully it has implemented all the correct functions. So after using the generic emitter interface, I guess what I could do is... Yeah. These are source files using our generic emitter interface that provides actually no, we don't directly reference this. Use standard lib of functions to generate lib references current emitter. The current emitter backend. And then from this, we get either one of two things. We either get language output, like build target, or we get LSP output, because I do want to experiment around with, like, I want code completions. That's a really good... Basically, I want to be able to inspect functions, see if there's documentation for them, see what functions are possibly exported from a module. When you're dealing with something like Vulkan, for instance, like code completions are like a necessity. And my use case for this is an engine where I'm going to be implementing Vulkan stuff, potentially. Potentially is the use case for the engine. I might just stick with using Rust as C, just crusting all the way. Yeah. So one thing to make this actually usable is LSP output, which means all of this... Hello, we're just messing around with a funny compiler toolchain idea. So all of this is probably contained within, like, we probably have a compiler binary, or not compiler, we probably have a toolchain executable. Now, what this is written in, straight up doesn't matter because it doesn't exist in the final build target. So might as well write this in Rust, to be honest. I'm probably gonna write this. Yeah, we're gonna write this in Rust. Because it's easy. It'll be easy to make this thing. So oh, I was already writing stuff in Rust. Nice. So instead of all this, I guess I'll keep the CLI arguments. That's good, because this is already going for the same idea. But now we don't need a parser anymore, because we're just going to use Lua parser. Don't need types because we're just going to use Lua's types. This is NeoVim in Windows PowerShell. I get asked about that fairly often, and it always brings me joy to break people's soul with that. Okay, Rust, Lua, JIT. So let's just get Lua JIT in here. Okay, AutoMod actually got the viewer seller. Deny. But oh, this looks like it's gonna be so easy. Oh, and that's, yeah, this is gonna be super easy to make. I'm hoping that I'll have something working by the end of the stream, because we're just using pre-existing stuff to build pre-existing stuff, basically. We should be able to have a hello world working by the end of the stream, hopefully. We will see. What do I have this named? Just Killer? Okay. I do wonder, for embedded Lua, how do you deal with require calls? It's funny you mention that quote. It's funny you mention that quote, because we kind of have that quote up there. Which explains a lot of things I do. But then again, I don't think it'll be easy most of the time. I'm just like, I'm doing this because I think it's going to be fun to do the hard thing. Though I've decided, like, I want to actually finish projects, so we're starting to maybe kind of do easy things sometimes, but still hard things. We're just using the easy things to do the hard things better. Right, require calls is embedded. Use by default. LuaJIT attempts to use the standard Lua loading paths. This application typically overrides or extends behavior. Must register a C function with the Lua state using the C API. Lua set global Lua push function will be called whenever require occurs. Operator dot. That's how we'll have to handle. We're not, since the loader or the emitter is going to be a different file. I guess we do have to worry about importing immediately. Yeah. Do I want that exposed to the actual build scripts themselves? I think I kind of do, because that allows us to have a project where it's just one bit of source, and it's able to build multiple languages at once, which would be really cool. Yeah, so let's add LuaJIT. Is it just called LuaJIT? Yeah. There we go, we have LuaJIT now. What is generative programming? So generative programming is kind of a made-up term, but multi-stage generative programming means you have one programming language that generates another programming language, like intentionally. That's like an exposed thing. It's not like secretly behind the scenes we make C and then like just compile the C, and you'll never know that there's C back there. No, it's like explicitly we're writing a language that writes another language. It is a form of like extreme metaprogramming, but specifically this form of it, like if you want to look up research papers, multi-stage programming is what gets you the that's what gives you the research papers on what we're doing here. So, yeah. Let's do Lua dot. There we go, we have a virtual machine. It's that easy. I spent like 3-4 years trying to make my own coding language when it could have been this easy to have a coding language as part of an engine. Now, okay, so this is giving it access to all the different libraries. Okay. So if I do load, okay, so I can load file directly. Validates that the file exists before passing it. The thread status. Okay, yield runtime error, syntax error, memory error, message handler error, file unknown. Okay. I think for now, we're literally just going to do load file like that. So we're not writing a C compiler in Lua. We're making a program in Lua that writes C code, and then we're just going to use CLang to actually compile that. Here. Do I have... Okay, yeah, I do have CLang on my path. So we can just do system. But no, so we're going to use Lua as a metaprogramming language. So all of our macros written in meta, our entire program written in the metaprogramming system. Because my complaint is always I don't have enough metaprogramming. So why don't I just have an entire scripting language to write my programs? Not like how some programming language compiled to C. This is going to be closer to how I was using a JIT compilation language, where instead of just doing an addition symbol, I called like an add member variable on a writer thing, but hopefully more ergonomic than that. It's closer to that. So Zig's C programming? No. They have metaprogramming. They have a lot of like compile time stuff, but no, when we click run on this, we're gonna get a C file as output. Not a not a actual runnable program. Now we're gonna extend our pipeline to actually get a runnable program from this. But yeah, I've either gone off the deep end completely or reached ascension. But okay, we're not gonna do this source file. I am a little bit thrown off by how like this might do everything. Does load file run it? Does this run my program? You know, let's see. So load file, so do file loads and runs the given file, returns Lua okay if there are no errors. So what does Lua load file do? Okay. Mode equal to null, loads a file as a Lua chunk. This function uses Lua load to load the chunk in the file named file name. If the file name is null, it then loads from the standard input. Oh, okay. The first line of the file is ignored if it starts with a hash. String mode works. Function Lua load. Function returns the same results as Lua load or Lua error file for file related errors. As Lua load, this function only loads the chunk, it doesn't run it. I'm guessing Lua load just loads a chunk without running it. There are no errors. Lua load pushes the compiled chunk as a Lua function to the top of the stack. Oh. Otherwise it pushes an error message. I understand it now. So basically, the reason I'm in a Rust file is because we need some toolchain to wrap this entire thing of like choosing where the build target goes, like give us like a command line executable that actually runs Lua for us, so we're not just like directly calling Lua on our code, which I guess we could implement everything in Lua, but I want to have LSP output as well, and I want to use libraries for that and Rust as libraries for that. I guess we could write everything in Lua if we really wanted to. Actually, no. For the language server protocol, we do need to be able to embed it. We do need to be able to embed it. So Lua. Why not embed it in Lua from the resulting C file? I'm not sure what you're asking. Right, stack machine, so... How do I read stuff from the stack? See this. So get top gets the index at the top of the stack. Okay. Why does get push onto the stack? Like it's the memory allocator. Fills the garbage collector. Oh, that's cool. I can actually turn it off and on. It's really cool. Copies an element at index from index into L. Blah, blah, blah. Function is exactly like Lua call, but allows the called function to yield. Now we're running everything synchronously, but that is good to know. Arithmetic there. I guess this is how we do error handling. Your panic function can avoid this by never returning. Oh joy. Is there a similar project you can look up? Yes, it's called Terra. So we're not going to do all the JIT compilation stuff they're doing, but it's what we're doing is similar to Terra if we only used... Where is it? Somewhere in here. Yeah, if we only ever used TerraLib's save object and never used the embedded JIT functionality. That's very similar to what we're doing. But instead of save object, we're returning a C binary that we're going to compile. So we're going to have all the functionality of save object, but yeah. Oh, right. Lua's index state starts at 1. I'll live. Or can I change it? such a hack. Is there like a flag I can... Entire fork of Lua, that's just zero-based indexes. Though I hate one-based array indexes enough that I want to use a different language. The only other option would basically just be JavaScript. I don't want to deal with JavaScript. I do not want to deal with JavaScript. Or embedding JavaScript. It would have become the very thing I sought to destroy. Internal convention, I'll just... completely forgot about this when I was... You'd have compiler flags to switch it. Be individually done for each function. Hash and table creation. Big posting king. I'm trying to decide how much I'll work with lists that aren't going to be in the target, and therefore I don't need to worry about it. Honestly, thinking about it, I might not have too much of a problem, except that there might be mixed. It's the ultimate goal of making the language, to see if it works. This is entirely an experiment. I want to see how far I get, just like in a couple streams, and see like, hey, can I implement a Vulkan triangle using this? Maybe something simpler than a Vulkan triangle, but that's kind of like that's going to be my gauge, is like, if it's easier to implement a Vulkan triangle with this than I mean, it would be easier in Rust from the get-go, but like once I get all the infrastructure in place, which one of these is easier to work with? And like if this is tolerable, I might actually try to write an entire like small engine in this just for the fun of it. Where the advantages it would procure, I want to write in C but with better macros and templating. And I could basically do that with this. Here, 1 second, I'll be right back. Hardest thing to solve for all of this will be, I don't know if I can get an LSP working to the point where I would want an LSP to be working. Because I'd essentially, isn't that just Zig? No. Zig metaprogramming, to my understanding, doesn't have access to type information, and I want to have access to type information, which I will have with this. I will be able to programmatically with a script manipulate types. Promise not. What? There we go. Why would you want to manipulate types? You have to do so much metaprogramming when you do engine stuff, like so much. Enough that like I've consistently run into situations where I'd really like to manipulate types. It's something I run into. Not like a ton, but when I do, I really want functionality like this, and no programs have it because it's rare enough that most people just suck it up and get around it. But no, there's like a ton of like, and there's also like small situations where like depending on the attributes of a type, I might want a function to run differently for like optimization reasons or whatnot. Or I might want to not have to write like 5 different versions of the same template to specify for like slightly different situations and whatnot. Sometimes I want to like, it's like the same thing except for like 2 lines. What if I could just have a conditional compilation thing going there? Yeah, which I can't actually do with C++ metaprogramming, but C++ metaprogramming is C++ metaprogramming. Here we're calling this now Lua. I got completely distracted. Reference to the table at index T for the object on the top of the stack and pops the object. The integer key is the table of reference is a unique key. Type value at the given index. Of a function. Globals are the name of our local variables. Is there set local? What are up values? Because of lexical scoping rules and local variables that can be freely accessed by functions defined inside their scope, a local variable used by an inner function is called an up value, or external local variable, or simply external variable inside the inner function. So a local variable used by an inner function called an up value. Okay. So we have this. That's a function. So that's how you scope in Lua. Without curly braces, you do and end. Okay. So up value. See, you have to load a chunk and then change the value of its first up value. Function index. Does the value of a closure's up value? It assigns the value on the top of the stack to the up value, returns its name. It also pops the value from the stack, right? Turns null and pops nothing when the index n is greater than the number of up values. Parameters function index n. I guess I'll figure that out. Cool that I can explicitly call meta methods. To retrieve values from the Lua stack in the C API, use the Lua2 family of functions. Often after using the Lua is functions detect the type of the value. So identifying the index items from the stack are accessed by their index. Positive indices start from 1, while negative indices are relative to the top of the stack. Checking the type, optional but recommended. Yeah. Retrieving the value, use the appropriate Lua2 function. Okay, 2 number, 2 string, 2 user data. Okay. That makes sense. Is it? Okay, no. Hello. How's it going? Which one of these? How do I get a table? What I want to get is a table. So we're doing fun programmer generate that. Funny, not coding language, but metaprogramming stuff. We're not making a language. We're just abusing an existing one. Once I figure out how to use the C API for Lua. I mean, I can't think of anything else that's not JavaScript that is like a fairly fast scripting language with a C-ish like syntax. Because like I'm not gonna use Python. I could use any one of these things, but yeah. Lua is kind of the easy default option for what I'm trying to test out right now. Could it possibly be that indexes start at 1? That could be it. That could be it. I don't know if I'm going to be able to handle that. I might have to use something else. I don't want to use Python, though. Do not want to use embedded Python. I could. In fact, I've already stumbled across it. There's our fork with 11 GitHub stars. It's Lua 5.3.4 with just arrays start at 0. That's the entire fork. Thing is, like, it's like considering using LuaJIT for this. Because LuaJIT fast, I don't need something fast for this. I'm just like, oh, I can just use LuaJIT instead of regular Lua, and it will be fast, and it will be easier. It'd be kind of funny to use the repo that hasn't been updated in 2 years for the funny of Lua 0. That would be really funny. I would just fork this, and if I need to make changes, it's so cursed. Use like a bunch of little workarounds. I guess that is like a valid, like... Question is, do I want to test my language generator idea quickly, or do I want to spend time trying to figure out the perfect language to use for this when, like, Lua or JavaScript would do fine. I don't want to use JavaScript though. JavaScript would kind of be fine. It would work. I don't want to use JavaScript though. I don't like Python syntax. I don't want to be writing everything in Python because, like, if this idea works, I'll probably make a small engine in it. I don't want to do that in Python because that would be cursed. That'd be cursed for all my source files for an engine to be in Python. Even if it is getting compiled to C and Python is just a metaprogramming layer, that would still be really, really cursed. And thus Lua 1 was born. But then that's just Lua. That's just Lua. I guess Ruby has a lot of metaprogramming stuff. Lisp would be absolutely perfect. Lisp would be exactly what I want, but it's Lisp. I don't... Do I want all of my source files to look like this? No. I do not want all my source files to look like this. But also, do I want all my source files to look like this? This is less terrible. This is less terrible, but I guess if we're going down the list of dynamic languages, we could try Ruby. This is classes. I don't want classes, I want an imperative language. Could use brainfuck. Imperative scripting languages. We'll just search that. What are our options? Hear me out. Hear me out. What if we do... What if we code everything in BASIC? Oh, they even have lambdas in BASIC. Perfect. It's BASIC? BASIC has go-tos. I know BASIC has go-tos. Yeah, BASIC's amazing. Perfect. We are not using PHP. We are not... No, I'm biased against this one. No, maybe... What does our syntax look like? Alright. See you around. I'll come to... Actually, I should make it to the 1,000-person load test. I don't like making promises, but I'll try my best to get there. I will try my best to be there at the 1,000-person load test. Oh, my valve body's in the mail. Amazing. I mean, if you're gonna get to 1,000 people, I might as well try to help you out with being one of those 1,000 people. Or 8. Yes. I'll ping the Discord. We'll get the boys in. Alright, bye. The images. Our syntax. What does this look like? All I've known this programming system for assembly, and we'd be right back where we are. Why can't people just make... There's one I used to look at a ton, and it's called AngelScript. It's a scripting library that I don't know... It's been forever since I've looked at this thing. But... object-oriented. With declaration of classes, I don't want classes. So we're doing... The goal is extreme metaprogramming. Like, what if instead of a macro syntax that's weird and completely different from the language, what if the entire language was only macros? So you have a lot of compile time compilation stuff going on, and yeah, you don't need a macro system because the entire thing is a macro system. You don't need a template system because the entire thing is the macro system. And then it all just outputs like a C file. You run Clang on the output C file, and then you have an executable. But right now I'm having a little bit of like, I was originally ready to just like go with Lua, but now I'm realizing like we're going to be outputting code with Lua, and I want this to be ergonomic, so I'm not like thinking about the fact that I'm emitting code, I'm not actually writing code. It is actually going to be very functional. It is going to be... You mean functional coding language? Lua. I keep saying don't want to do Lisp. Written in Rust. Declarative is complete opposite of it. I don't want object oriented, basically. I'll look at Gluon real fast. Of course, it's a quantum physics thing. It's kind of what Brain was inspired by, is this quantum physics thing, so I can't laugh too much. I know object-oriented is a child of imperative. It's not the favored child. Let's see, Gluon. Statically type inferred. It's statically typed, so it doesn't match my dynamically typed. So it run at a compile time thing. It's Rust syntax. Wait, why did they do Rust syntax and then add do in there? Like, do I go back to just making my own interpreter because I can't deal with anything else that exists currently? Why are there so many Rust embeddable scripting languages? I mean, yeah, I write Rust and I also write languages. But like, Why? Can I get an example? Can I have example code? There we go. Standard Fibonacci sequence. Okay, I like that syntax. That's good syntax. Is it dynamically typed? Uses a domain-specific language, disables certain language features such as looping, further restricts the language by disabling keywords and operators, define custom operators, extend the language with custom syntax. Okay, this is very close to what I want. Yes, metaprogramming language. Not a programming language, but using a programming language to write another programming language. Similar language to JavaScript plus Rust with dynamic typing, fairly efficient evaluation. Yep, tight integration with native Rust functions. Types. Which types? Does it work with enums? If this has enums, it will immediately sell me. What types? With any Rust type. Custom stores, specifically a dynamic Bri variant with no restrictions other than being a clone. Okay, yeah, this works. Yeah. Or specifically the name I haven't been saying on stream because I don't know if family members can hear me. This is what it's for. If you want to know the tone of what this is for. Depends on what type of enum. Object-oriented programming, as defined by the creator of object-oriented programming, would have better been named message passing because of the interface of, like, you have objects sending messages to each other, like cells communicate to each other through, like, sending stuff to each other. That was the original idea behind object-oriented. So that's what I think of in my head as object-oriented, along with, like, inheritance and stuff. So interfaces don't necessarily super, like, once you get to an interface that's, like, maybe object-oriented, that's getting into the realm of object-oriented, but, like, enums, no, that's just, like, that's a discriminated union. Or Rust enums are discriminated unions. Okay, I guess how... It says... This is an established project. Yeah, we can use this just fine and not worry about it too much. This is actually kind of perfect for what we want to do. Nope, there we go, we're back. Alright, hopefully the YouTube stream didn't end. Okay, we're good. We're back. Okay, features. Dynamic typing, tight integration with native Rust functions and types, including getters, setters, methods, and indexers. Usually call a script-defined function from Rust. Very few additional dependencies. Now only small vector, thin vector, num traits, bit flags, smart string, for no standard. WASM builds. Fairly efficient evaluation. Yep. Function overloading, operator overloading, organize code base with dynamically loadable modules, optionally overriding the resolution process. Resolution process. Okay, so that's import statements. Dynamic dispatch via function pointers. Okay. Actually, wait. Why have I never heard of this project before? This is a lot of the similar ideas to what I was trying to do with RainScript. Don't care about this. Never panics the host system. Good. Protects against malicious attacks. Nice. Track evaluation progress. Ow. I can immediately think of problems with figuring that out, but okay, what isn't it? No classes, no traits, no structures. It's not viable because it doesn't have structures. The entire point of the... Dang it, I was sold. It doesn't have structures. Lisp technically doesn't have structures either. Yeah, it's just a thing. Technically, JavaScript fulfills all of my requirements. I just hate JavaScript. Is my bias holding me back? Blue would be perfect if it was 0. So this is not currently part of a larger project. This is just me experimenting with ideas. Specifically coding toolchain ideas. I don't want one indexed arrays to be a deal breaker, but it kind of is because I'm going to be trying to write code that seems like it's the same code as the destination language. And if I'm doing that, exactly. But if I'm doing that, if I'm mixing code that expects 0 indexes and 1 indexes, I'm going to make mistakes, and they're going to be really annoying and hard to debug, and I'm going to hate Lua every time it happens. So I would like something that is basically just Lua, but with 0 indexes. We're going to use this as a search engine. We're not vibe coding. I have a local LM for that. I don't trust the big tech companies for that. See, is there a legit language that's like Lua in terms of syntax? C like syntax and embed ability that also has 0 based indexes. Often called Lua with classes. Don't want classes. AngelScript is the thing that I brought up before that I had been looking about before, designed to be as close to C++ as possible. I want something that's C. Wait, actually. No, because I want member function calls. What is do with classes? I guess if I just don't use them. Think Smalltalk in a Lua-sized package with a dash of Erlang wrapped up in around a familiar modern syntax. Small, the virtual machine implementation is under 4,000 semicolons. Small but not dense. Fast. Single pass compiler and bytecode and all that seems. I want the ability to runtime generate stuff, mostly. The idea behind this idea was that like I could just do Python or Lua real fast to figure out how hard something like this would be. But now I'm getting hung up on really simple details. I'm losing the plot. Python is like really slow to the point where like if my source code is written in Python, and even if it's a single pass compiler, like that's the point where like the scripting language actually could slow it down. And it's like weird class stuff and whatnot. No, I do want dynamic typing. Dang it, for this idea, to have it actually the way that I want it to be, I would... Thought I was having a moment of like, oh, I'll just use the existing things. Like, they're good enough. How much free time do I actually want to sink into this? Is it a good idea to spend as much time as it would take to actually make, like, interpreter? Well, it depends on how long it takes for me to actually write this. It does make code less readable, but consider the fact that it's not actually dynamically typed. Only the compiler is dynamically typed, and all compilers are dynamically typed. So, okay. We need to create the absolute bare minimum virtual machine. And I want this to be running in under an hour so I can start working on stuff. So, still doing Lua call stuff. Was this not checked into Git? Oh crap, I just deleted code that wasn't checked into Git. Okay. How fast can I write this? Okay. So what features do we need for this dynamically typed language? We need floats, ints, the ability to define these as constants. We need objects, we'll call them. We don't need operator overloading yet. We actually don't need operators at all. We need first class functions. So these are so functions as values, which in an interpreter isn't hard to do. I really want enum, or discriminated unions. How do you do that? Discriminated unions in... So we'll call them tagged unions. Yeah. Call them tagged unions because they'll be discriminated by a tag, which we could represent as objects. Okay. Floats, ints, tagged unions, objects, functions as values, and these values can either be defined by code or defined by runtime. And okay, how do we handle our stack frame? Let's define this entire thing as a stack machine. That will make it just, we don't have to worry about memory management whatsoever in there. Stack machine pointers are just reference counted. So by 9:45, we'll have this running by 9:45. Now, we don't actually need tagged unions. For the MVP, technically we don't need ints either, but I'll just go with it. So the first thing we need is a parser. How fast do I think I can make a parser? Now, the thing with the thing with Chomsky, the library I usually use, is it's like really hard to debug generator expressions, so I just want to do recursive functions, and that's my parser. We're going to keep this as simple as possible so we just don't have to debug it. So let's see, parser honestly might be the hardest bit, so let's say parser by 9:10, and if we're working on the parser longer than that, we will have failed. So just lock in. First thing we need is a tokenizer. So first we have an identifier. Identifiers are just a string, and if this wasn't Rust, I would do interned values. We can intern it later. It's fine. Identifiers, I'm not sure what other syntax we need yet. We need we have function as like a thing. We have any other tokens that I can think of. Open parenthesis, close parenthesis. We have open. We also have why did I define these before? I already have these tokens defined for brain scripts, so I'm just going to copy them. So this would be underneath compiler, parser, source. Right. Did I backtrack on using tokens? Hub token. Yeah, I backtracked on using tokens because it made it hard to work with Chomsky, and that was fun. So instead, we're going to do by look at the history. This. Losing. It's using my token method. I split compiler into many crates. There it is, crate tokens tree. Somewhere in here. Is there a way for me to view the repo at this stage? Browse files at this stage. Then see tokens. There we go. You don't need to define all of these. But do I define span as well in here? No. This is what I need to start out with. There we go. And now, let's see. Implement peaking functionality in Rust people method. With an offering to you with a reference to the next item. Look for looking ahead in connections such as parts. More than one element. You can use multi-peak functionality from the iterator tools. Great. I'm not going to worry about fancy Rust iterator stuff. We're just going to go struct. We're going to call it iterator. I can make it fancy later. Feel like I'm kind of wasting time just writing a tokenizer. Here's what we're going to do. Where is... Since I don't want to spend forever writing this tokenizer, and like, it just needs to work. Take a slice string input and output a result that is either a vec of tokens or a unexpected error. Now let's see how well the local LM can deal with this, how quickly. What did I set for myself? 910? But it should be able to burn through this fairly quickly. If it actually goes. I've only tested this thing with JavaScript so far, which, like, LLMs are very good at JavaScript, so, like, a local LLM can speed through that. I don't know how fast the local LLM will speed through Rust. That's what we're about to see. Like, it's doing something. I don't want to wait too long, or I have to accept this, that this will take longer than I want it to. Longer than my, like, super short demo time. All those Rust rewrites, it probably has a fair amount of data. Like, actual models, not like quantized things that are just like fill up all of my VRAM. These ones maybe done with request. Not done with request. Took that long. It's usually a lot faster than this. What is going on? Does it not have VRAM to work with? Might not have VRAM to work with or something. Okay. That is not doing stuff. So I'm just going to clod this because clod is going to be very fast. Okay. Me when I want to move fast and I actually use AI, like the corpos want me to. Ugh. Stone output input for the first function should just be a string slice, and output should be a result spec token with an unexpected I guess. And it's going to go zoom, and it's actually going to make it because Claude is actually really good at this. Yep, it goes zoom. Here we go. Here's our tokenized function. That gets everything that we want. Like that. I'm gonna throw this at the bottom here, for organization's sake. So now, we have this. Context generic and work for any I actually want to use this context for I want to use just exactly this, but for not for the next stage. So this is going to be a context of, I guess, what's it returning? Peak option T, so it'd be char? Char. And call this one just to be tokens. This one is going to be I'm just gonna call it characters. That should work fine. Now, 3 minutes to go. No. I have to define a very simple syntax here. For floats, int objects functions as values. Okay, we need to expand our thing to like 9:30 to be done by. Okay, we need some form of control flow here. So I'm gonna allow myself match statements. Tokens. Tokens is just going to be a vec of tokens. Now, technically, in an ideal world, we would have multiple results, multiple errors and whatnot. Now we're just gonna have a span and a string, and I have a lot of, like, I know how to make a very detailed, like, there is a way to make a very detailed version of that, or error output, I mean. I define span? I have not defined span, so I'm just going to define this as range size. And the result here is going to be what is the result of this going to be? Because theoretically, I could literally just write the language right here. This could be my interpreter. This could be my interpreter. Right in here. We could just take a stream of tokens. So I'm going to rename this to Lexer. That's what it does. I'm going to say let source equal to read to string. This actually brings us back on track. Yeah, this actually brings us back on track to, like, I'm on the timeline I set. Now we have our source. Let tokens equal, and then did I keep my tokens structure? I did. Will it ever backtrack? Ever? If I write this correctly, I shouldn't need to ever backtrack when parsing. Yeah, let's see. Okay. Now tokenize should return tokens or tokens iterator. Yeah, I actually can't think of a lot of scenarios where I would actually need to go backwards. So this might, maybe, just work. Okay, so we want the output of this to be I guess at this point we want the output to be a C file. No, he does not. Never. Let's see, what? There's like our things, but what's our output? Rose gonna code his car soon? No, unfortunately to reprogram your car you need really expensive software. And I don't... My car's not old enough to actually need to be reprogrammed. Technically, I actually did reprogram the valve body with the shift kit. Bottom left of the stream. Ah, yes, the one with the broken icon, because I never fixed that. Yes. Yes, so if anybody wants to not use the keyboard in VR, use this thing, made by one of my friends, because it is good and won't crash your Steam VR instance. Alright. Yeah. Sure it won't. No, it's pretty good. It's pretty good. I actually use it on occasion. I will let you know, earlier in this stream, I was like, I'd prefer to write my... Essentially, the conclusion I came to is I'd prefer to write my own very simple scripting language instead of just using Lua, JavaScript, or Python. Like, I was so close to just using Lua and just testing my hypothesis that, like, you know, this idea would work. Like, using one coding language to generate another coding language and it will be super ergonomic and, like, cool and stuff. But then I'm like, no, I don't like any of the existing scripting languages. And I'm like, no, I'm doing it again. I thought, like, in 2 hours I could test this hypothesis and have, like, a fully compiling program and maybe, like, try writing some Vulkan bindings and whatnot with it. No. I need to write my own scripting grammar and stuff because, like, I can't handle anything else. There was one language that I was really close to using, and then I found out it didn't support structs. I was like, okay, it doesn't support objects, so I guess, yeah. it's screwed. But what do I want the output of this to be? I guess I need the output to be a structure. The structure that defines my binary, I guess. Output. What if I provided the script intrinsic functions to, yeah. No, I still do need a way to... Do I still? No. I'm not linking to anything yet, so we're just gonna say evaluate. Results. Nothing. String. Behold my glorious error messages. We're going to evaluate our stream of tokens. Don't ask why tokens is mutable. It's because it's an iterator. There you go, you asked. So let's create another... This is just our virtual machine state because we're going to need that. There we go. Now, this also we'll need... Does tokens go in the virtual machine state? Yes. Also, screw having a new function. We're just gonna manually create it here because it's faster. To evaluate our virtual machine state, we are going to do while tokens, while let e equal tokens next. Boom. We have a virtual machine, and now we're going to match on T, or let's say let do we always need it to be an ident? Basically, if let, actually we're gonna say let VM state iterator. Oh. State tokens next. There we go. Let token kind. We need this to be an ident. Identifier. That does implement display, so we can just string format it like that. Now, we can just match on the identifier. We can say here, okay, so what possible identifiers could we have to start off? We could have a function. We could have let for variables. What do we do with function calls? Well, I guess since we want to do a hello world real fast, we need to do our hello world is going to be here's our test p function. We'll call it pill, test pill. Let A equal to, let B equal to. This is a more complicated. I'm not gonna have any operators at first. let statements are... How much pattern matching do I want to do at first? Okay, so we have expressions. In this language, we only have expressions. So what expressions do we have? We have literal expressions, which is float and int. We have objects. We try to reduce ambiguity. Dang it. I'm not going to be able to make this as fast as I want to, because I want to make it fancier. But I need a fancy parser for the sort of thing I want to do. Do I need to make a fancy parser for the sort of thing I want to do? Kind of. I need to make a fancy parser. How do I tell the difference between a... How do I tell the difference between an object literal and a... creation of an object? How do I tell the difference between that and just creating a scope? Everything's an expression, just everything here is an expression. Also, the first thing in here could possibly be not an ident. 10 minutes to my deadline of code being written or evaluated. How do I get there in the time of my deadline? Well, we do... Okay, that's okay. This is why people use actual parsers instead of trying to make jank stuff. So basically, the thing that I've been muttering to myself about for the past little bit is the fact that, like, okay, let's say we have a scope here. Inside the scope are expressions. Like so. Now, what if I also have the creation of an object? Like so. Key value, yeah, that's object. Do I have to create... I really like creating objects with this syntax. How do I determine the difference between these two? Jankily. Instead of this, we're going to match on T kind, like so. And if this is an ident function, we're going to say do. We do actually need to implement let statements for just going to say unexpected. Wait a second, we've already consumed this token? Yeah. Yeah. Now in here, if this is a token kind, open brace. Yep. Then we need to if let or we'll just match on state tokens. P2 this entire thing needs to be we just need so okay, with no value. Actually, we need to define our values. We are gonna have a nothing value for when expressions return nothing. We're gonna have int, which is just going to be an I64. We're gonna have float, which is going to be a F64. We're gonna have object, which is just going to be a hash map of a string to value. And we're also going to have, and this value is going to be reference counted. This is going to be a implements Can ref cell do dynamic dispatch? A dynamic mutable function that takes in a mood reference to VM state. And I guess since we're doing a stack machine, we are doing a stack machine, I guess. No, we have named values, so we're not gonna do stack machine. We're gonna do object machine, or whatever that means. So we have the VM state, and then we're going to have a vector of value that it takes in as input, and then we are going to output a result value. How do I account for? That's how we'll account for it. Sweet. Next one. Then in here, we'll just say p equals state. Next. That will actually be fairly easy to implement. Okay, we're over our timer, but I'm not too concerned yet. So let's do open brace, next pair, return. We could put braces around a single value. Or for now, because we want to have a really fast parser, and we could do a really fast parser with this. I don't like the new keyword, but we could do a prefix to just say that we're creating an object. Like that. Now there's a prefix. We can always just parse forward. So instead, here we would match on ident as string, like so. In open brace, we would just do while state tokens peak to or peak. Need to check for end, but I need more code space than just this. So I'm gonna do a function here, just aside from just the state, we're going to have a token kind. This will much more Rust way to do this. You're just gonna say return expected end value. Like so. Yeah, that's basically it. Okay. Well, not is closing. So while this is not a closing brace, And here, this is our scope. So then in here, to evaluate the expression, we just run it again. We pass in our state. Okay, I know how to do functions. So when we evaluate that function, we're literally just going to evaluate the function. Basically going to do lazy evaluation of them. I'm doing this range so that we're not just straight up copying it every single time, like we do with objects. You could just straight up do tokens. Now, when we're matching this identifier, I actually am going to define let statements here. So we have object state or object expressions. We have let expressions, and we have call expressions. inside our VM state, we're going to have do I want to implement scoping at this point? Kind of. Kind of, yeah. Eventually, we will need to store more data than just that. Yeah. If scope is empty, we'll just push a default scope. Actually might make sense for all these functions to be members of the virtual machine state. That might make sense. Here we go. Hang out equals I'm actually going to loop here. If is next, token semi. No. Actually, I'm gonna say if is next, closing brace. Say give it a, I'm gonna try to create a try consume. So try consume will be if is next expected next state next, and we're going to return the reference. Say if try consume token semi and this is like my scopes, my version of Rust's scopes as values, or yeah. I can just check if return value, that's a value. If not, try consume semi colon. If we did not consume a semicolon, we tried to consume and there's nothing to consume, then return value equals value sum value if Here we're just going to do if is not next closing brace. So this is LazyBone, yes. Technically a custom config of it. So that takes care of scopes. Actually, wait. God, what we do want to do is state scopes push. I want to push a new scope here. At the end here. Not in the middle of the scope. I'm gonna put a to-do here. Or actually no, a to-do here. This pops from the last element. Yes, okay, so push, pop, that works. Right now we're working on, I was originally going to do this with Lua, but then I decided, I looked at a bunch of other scripting languages as well as Lua, and I decided, no, I prefer to just do a custom scripting language for this. Basically, the idea is to have like a small, very simple like generator scripting language, and then to use that to generate more advanced coding languages or simpler coding languages. So you basically a metaprogramming language that used to generate a target language. It's a concept called multi-stage programming. And the idea is that you get a much better macro system that way, and templating system, and basically don't need a templating system or a macro system because you just have a scripting system that runs at compile time. And you just run the script, and the output of the script is the program that you want to compile. Yeah. Okay, let's do variable definitions next. So I wanted to have this working by 9:45. It's currently 10:16, so we're probably going to be like an hour off. Say let name is equal to try consume. Then we want a token find. Ooh. Items are wildcards. So we can't exactly use regular code here. We need to use the is next. Tokens be expected. The ident. Is ident here, and also a function is literal. We can all do the same thing as is next, but they're a little bit more wild card. Here we want to do ident. We don't care about the value. Oh, hello, Jack. Not right now. I'm trying to see if I can get... I've gone a little bit off the deep end. I'm back to custom scripting language. I was going to use Lua for a quick prototype, but I'm going to try by the end of the night to actually have like closure on something. So my goal here is to have like a working scripting language by the end of the night. So not much marathon time. No, I don't want error here. Ye. And hope I wish good games upon you as well. I know the simpler version of this. here. We want these to return. Want to keep span data just for cleanliness here. Just like that. Okay. Now, here on let, try consume ident. Expected variable name. future, this will be try to consume a pattern matching statement. So now, what next? Next, okay, and finally, we need value equals expression. And then the expression we can evaluate here. Here we're going to evaluate expression, which is the state. And then in here, we're going to, actually up here, There we go. And now we can loadably reference variable. Wait a second, we don't need to get a variable here. No, I don't care about variable redefinitions. That covers setting variables. We now have the ability to set variables. Now, we have an unknown variable here. We're actually going to do I guess I should check if this is an assignment first. To avoid circular references. I guess we could check if it is callable. RC rep cell. Only the ones where it matters should be rep cell. Maybe objects should be colored rep cells. Right. Drive clone right there. If we consume an open parenthesis, that means arguments. Assume comma. Next is not close parenthesis. Expecting a comma. Close parenthesis. Okay, it's all of our values, and then and we try to call it. Callable value, then okay, match on callable. Objects might be callable. They will probably be callable. Right now, Eventually I need more analysis than that, but for this, that'll do. Yes, variable argument. Variable argument will be hard to pull off here. Question is, do I want to translate function param? No, wait, I'm not editing the buffer, so it wants to deal with Vardic args. That's how we'll have to deal with them. That is an extremely janky hack, but it will actually, this will work. This will have the effect of calling a lambda. It might not capture global variables very well at all. But it will do the thing. Script should be defined as a function. I'm gonna do the most jank thing ever. Okay, so now, theoretically, 2 plus 2 might work. Maybe. Still working on your metaverse-like project? I have it on pause for the moment. Very much, unfortunately. It just wasn't really working for the time, and I'm gonna bring it back when I know I can pull it off, but that's not yet. Okay, now... Yeah, metaverse is the coolest name for any of that, but now the word just keeps getting worse. Now everybody's going to be like, yeah, metaverse is dead. Meta pulled out of it. They killed it. And I'm like, it was never theirs to kill to begin with. Are there any other... I have a virtual machine. How's it going? We are just doing dubiously productive scripting things. Very close to the first run of this interpreter. Since I defined it to be function, I don't actually need this to be ref cell. Also put it in the wrong place. Wait a second. I just realized that's the same exact case. Twice. This one we don't have to do the weird jank workaround for the return value. And here, that's how return statements are gonna work. For now. Terrible jank workaround. it's going to be in there for months. On it. We're gonna run this with selected variable name. Ooh. Huh? In what universe does it find? Found space. Do I have white space as... token kind? I do have white space as a parsable thing. How do I want to handle white space? Why did I have white space parsable in my original thing? Do I have a way to skip white space easily? Not really. Seems like, expect it. Okay, that will get rid of all the white space very jankily until I need it again. One. There it is. Why is my computer lagging out? There we go. Mission 59. guessing it's right there. Is my tokenizer... There we go. I should do the thing. Expected and equal. That's what there was, isn't there? What position? Status update? We're trying to run the first script now. So, I made a VM fairly quickly. It's very rough, but it might take... Expected found A. Okay, it's not supposed to find an A. In a couple days, this could be ready for use. Let A build that. Consume ident. It doesn't actually consume it. Rolls. There we go. Should be able to handle literals now. Okay, good.